Welcome! In this video, we are going to look at X-rays. X-rays are part of the electromagnetic spectrum. They overlap with ultraviolet and gamma rays on the higher frequency end of the spectrum. Next, we'll take a look at how X-rays are produced. First, electrons are ejected from a hot filament. The electrons are then accelerated through a large potential difference called the accelerating voltage. The electrons convert electrical potential energy to kinetic energy and strike the anode of the metal target. The picture shows a tungsten target and copper anode. There are two ways the X-rays are produced in this process. The first is called Bremsstrahlung, which is German for breaking radiation. This type of X-ray is produced as the electrons are decelerated upon striking the anode. The second process produces characteristic X-rays. They're called that because they depend on the anode material. These are produced when the electrons provide energy to the electrons in the anode, causing them to move to a higher energy level. The electrons then de-excite and drop back down to a lower energy level that's now vacant. And in doing so, an X-ray is produced, which is a high energy photon. The plot of the X-ray intensity versus frequency shows both types of X-rays. The smooth part of the curve is the X-ray spectrum due to Bremsstrahlung, and the sharp peaks are the characteristic X-rays. The highest energy X-ray equals the charge of the electron times the accelerating voltage, and that equals Planck's constant times the maximum frequency. The energy level diagram of the X-ray shows the different characteristic X-rays that can be produced. The shelf vacancies are labeled K, L, M, and so on, and that's after old notation, and they correspond to the energy levels N equals 1, 2, 3, 4, and so on. The K alpha X-ray occurs when the electron transitions from N equals 2 to N equals 1. And K beta, which has more energy, occurs when the electron transitions from N equals 3 to N equals 1. There are many applications in which X-rays are used. These include dental and medical imaging, though there are hazards such as ionization and damage of cells. Other uses include luggage inspection at airports. Diffraction is another area X-rays are used. Diffraction is the bending of a wave around an obstacle. This causes waves to interfere, which is the adding of waves that collide, so to speak. The result can be a bigger or smaller wave or even no wave. X-ray diffraction is useful because it gives information about the structure. One example is the discovery of the double helix structure of DNA by Rosalind Franklin. She was not included in the 1962 Nobel Prize that Watson and Crick received for their work in analyzing the data she provided. I hope this was helpful. Let me know in the comments section if you have any questions. Thank you for watching, and I'll see you in the next one.